everybody. How are you all? Hope you be great. Welcome back to another session of learning mathematics with me. Before beginning, I would like to request please subscribe the channel Tangent Academy. Also like the video and share it with friends too, because you will get one math problem or physics problem every day. We have selected today's topic as a project as conic sections. Very important part. It is very important part. It was Apollonius 262 BC to 190 BC who has given the name parabola, ellipse, hyperbola, circle. These are conic section, and at this time I will show all the conic section, how the cones are formed, how the sections are obtained. These are matter of things which we have to discuss. So today's topic is about conic section. In this session we will observe and explain that how cones are formed, how sections of cones are made. Also, we will explain the degenerated case of sections of a cone. Conic sections are nothing but basically a set of cones that we can obtain sectioning a right circular cone by a plane with different way of sectioning. Before beginning to cut the section, I would like to tell you how the cones are formed. Observe me. This pink axis is called axis. This is fixed line. As you can see here, this is fixed line. Another line, we will further name it as M, which is called generator. And one of the fixed point further we will name as V, which is a fixed point around which this generator moves at a constant angle, so that it can generate two cones on both the side. The condition is that this angle must be constant in order to obtain symmetry figure. So this is called apex. This is called apex, and this axis is called axis, which is vertical to the horizon. And this is the line which is called generator, which is inclined to this axis at a constant angle, which we will further named as alpha. So two cones are formed by rotating around this axis, this fixed axis, at a constant angle. Two cones are formed, the upper cone, the lower cone. These cones are called nappes. These cones are called nappes. Now we will section these two cones in different ways. And how the geometrical figures are obtained, let us see. First of all, this is called a plane. This is called a plane. Conic sections are basically a set of cones that we can obtain sectioning a right circular cone by a plane with different way of sectioning. This line is named as L, and this generator is named as M, and the angle made by at this line is called fixed line. This is fixed line. Further it will called directrix. While we will derive the equation of conics, it will called as directrix. This is fixed line and generator is here. This is axis. This is generator. This is generator. And here this angle is known as alpha. And this angle must be constant. So let L be the vertical line which is called axis, and this line which is called M is a generator, and the angle which is made by generator with the axis is called the angular inclination. And so two cones are obtained. Now we are going to section the cone. If we take the intersection of cone with a plane, then sections so obtained are called conic sections. We obtain different kind of conic sections depending upon the angle made by the plane with the axis. It was Apollonius 262 BC, 190 BC, who has given the name parabola, ellipse, hyperbola. Curves have wide range of application in field such as planetary motions, design of telescopes, antennas, reflection in flashlights. Let us start with the cones. How cones are formed? Which type of curve can be obtained by different way of sectioning a cone by a plane? The three conic sections can be obtained from only single neck or single cone. Three conic sections can be obtained from three conic sections. This is a cone. Three conic sections which are circle, ellipse and parabola. These three curves are obtained by a single cone. How? This is right circular cone. Because the axis is perpendicular to the base, so it is called right circular cone. This is right circular cone and base is circular. The line joining the one important thing, the line joining the vertex to the any point on the base is called generator. Again listen, the line joining the vertex or apex to any point on the base is called generator. Then what will be condition for sectioning a circle? The only one condition. This is called plane. This is called axis. This is a plane. This is a plane. Like that. This is a plane. When this plane cuts this axis at an angle of 90 degree, observe here, at an angle of 90 degree, then the section obtained is called a circle. But necessary condition is this plane must intersect or section this cone at an angle of 90 degree. The cutting angle with the axis should be 90 degree. So circle, this type of figure is obtained, this type of geometrical shape is obtained, which is called circle. Now we come to another part. ellipse. Ellipse. This is a circle. This is a circle. The shaded area is a circle because it cuts the axis at an angle of 90 degree. Another figure is ellipse. In the condition, the angle made by the axis with the plane is called beta. We will call beta, or the conical angle is alpha. Conical angle is alpha, but angle made by the cutting plane is named as beta. Is named as beta. So if beta should be greater than alpha but strictly less than 90 degree, beta should be greater than alpha. Beta should be greater than alpha and strictly less than 90 degree. Then such figure is obtained, which is called an ellipse. Which is called an ellipse. This is cutting plane. This is cutting plane. Where is ellipse? This type of figure is obtained. This type of section is obtained. So it is an ellipse. Now we have seen actually an ellipse has two diameters. Actually an ellipse has two diameters. The major axis and the minor axis. For the convenience, we take A dash, that is major axis, as 2A because center divides its equally, and BB dash as 2B. The fact is that actually circle is the special case of an ellipse. Again listen, circle is the special case of an ellipse. When this part is A, this part of A, this part is B, this part is C is center, this part is B. When A is equal to B, on that condition we will have such type of figure which is called an ellipse. So circle is an special case of ellipse. Always remember, circle is an special case of ellipse. Now we will explain about parabola. So until two sections are made here, which is called circle and ellipse. Now we represent the third one structure, which is called parabola. In case of parabola, this is axis, this is generator, this is angle alpha. Then in this case a parabola will be formed if alpha is equal to beta. If alpha is equal to beta, and condition will be the sectioning plane will be far away from the apex, So we cut this type of figure. This is a cone. This was a cone. I have cut this figure as follow. Suppose this is one of the generator. Among the infinite generator, this is one of the generator. generator. If we section when alpha is equal to beta, then alternate interior angles will be equal. Alternate interior angles will be equal. So this cutting plane must be parallel to one of the generator. Parallel to one of the generator. In such a case, this type of figure is obtained. This type of section is obtained. This geometrical figure is called parabola. This geometrical figure is called parabola. Again, I am coming in the case of hyperbola, both the cones are used. In the case of hyperbola, both the cones are used. Its condition is hyperbolic condition is the cutting plane must be parallel to the axis. Cutting plane must be parallel to the axis. This is axis. Sorry. This is axis. This is axis. These are two cones. Only hyperbola can be obtained by two cones. In case of hyperbola, two curves are obtained. Like as you can see from this figure. So that plane, where is plane? This plane must be parallel to the axis. This plane must be parallel to the axis. In this case, beta is equal to 0. Beta is equal to 0 degree. So these four types of conic sections are obtained by sectioning in different way by this plane. Four sections are obtained. Now we shall discuss some of the degenerated case. What is degenerated case? When the plane passes through this apex by any way, when this plane passes through this apex, then these four types figures are not found or not formed. In such a case, we say that these are degenerated case. Again, the important condition of degenerated cases are here, plane must pass through these points. This point affects. The first one, degenerated case, when the plane cuts the vertex of the cone, then we have following situation. Alpha is greater than beta but is strictly less than 90 degree. In this case, ellipse or circle. It is the degenerated case of ellipse or circle. Alpha is greater than beta but less than 90 degree. Alpha is greater than beta but less than 90 degree, and alpha is greater than beta is greater than alpha but less than 90 degree. Then this is the degenerated case of ellipse. Then this point will be left only. This point will be left only. Then we can say that degenerated of a circle, this will represent a point. This will represent a point. In this case, this will represent a point. These are the special case of circle and parabola. Next one is degenerated case of parabola. Parabola, in this case, when beta is equal to alpha, then edge of the plane must be coincide with one of the generator. See here, the plane cuts this apex and one of the generator, it is parallel, then it will only represent a line. It will only represent a line. Then what are the degenerated case of hyperbola? The degenerated case of hyperbola, when beta is equal to 0, therefore this must be, the edge of the plane must be parallel to the edge of the plane must be parallel to the axis, must be parallel to the axis. In this case, like as, but it must pass through this apex. In this case, two sections are obtained in such a manner that it will represent, its projection will be, it will represent an isosceles triangle which is a pair of intersecting lines, pair of intersecting line. Now we are going to establish the relation or general equation of all the conic section. The general equation of all the conic sections suppose this axis we have taken, here we will treat as generator, here we will treat as directrix. This is a fixed line. Sorry to interrupt. Very black. Let us take this fixed line. Sorry to interrupt. Where I have put that kind of things. Now, this is fixed line is called directrix. This fixed line is called directrix. And here we have set this line as an axis to form a cone. This is a moving point. Let us take coordinate of this point is xy. This is moving point. Draw a perpendicular PM to this line. Let the perpendicular distance is PM. Let the perpendicular distance is PM. Let the equation of the directrix be general equation AX plus BY plus C is equal to 0. This is also fixed point S called focus. Its coordinate is alpha beta. Its coordinate is alpha beta. So general equation I am going to be obtained. Let this point P moves in such a way that the ratio of PS and PM always bears a constant ratio, then in different situation, these four types of curves are obtained, like as circle, ellipse, parabola and hyperbola. Again listen, if the ratio of this fixed point, it is also fixed point, and this is fixed line called directrix. In such a way this point is moving, then the ratio PS and PM always remain constant depending upon the way of sectioning the cone, by different angle taking as beta. So I am going to derive the general equation for all situations. We have PS by PM is equal to constant. We have PS by PM is equal to constant. This constant is called eccentricity. This constant is called eccentricity. And symbolized as E. Therefore, PS by PM is equal to E. Therefore, PS is equal to E into PM. E means eccentricity. The name of this ratio is eccentricity. PS by PM. Squaring both sides, we can get PS square is equal to E square into PM square. PS, distance from this point, variable point P to the focus, called focus. This point is called focus. So its distance from this point will be PS. What is the value of PS? PS will be x minus alpha square plus y minus beta square is equal to eccentricity square into PM square. Interesting thing here, P to M. How we can find this distance? This is a line whose equation is AX plus BY plus C is equal to 0. Length of perpendicular from this variable point PXY to this line is given by the formula absolute value of AX plus BY plus C whole square divided by under root A square plus B square, coefficient of X square plus coefficient of Y square. This will give the general formula for any conic. The important thing is, depending upon the value of E, nature of E, we will have four types of conic section. How? Let us see. This is the general equation of a cone. Conic section, not cone. All the conic section we can use this formula. In rectangular form I have written here. When the cases arises. Point 1. When E is equal to 0. How it be possible? When PS is equal to 0, then this ratio will be 0. Then this kind of situation arises. Focus coincide with moving point xy. This is the general equation. Ax plus by plus c is equal to 0. In this situation, this focus must be coincide with the moving point. In this case, this constant this will remain same, and this type of generator will move in this way such that a circle can be obtained. So it is the case of circle. It represents a circle. It represents a circle. Next one is when eccentricity is less than 1, less than unity. Eccentricity is less than unity, then it will represent an ellipse. Third one condition is when eccentricity is equal to 1, that is in this case PS is equal to PM, then we have the section is a parabola, then section is a what type of figure? Parabola. Then the section is a parabola. And the last one, when eccentricity is greater than 1, then we obtain hyperbolas. In this way, we have find the all conic section, and this is the general equation of all the conic sections depending upon the nature of E. If E is equal to 0, this formula will represent a circle. If E is equal to 1, this formula will represent a parabola. If E is less than 1, then this formula will represent an ellipse. And if E is greater than 1, then this formula will represent a hyperbola. Thank you for watching. So I hope that this video will be helpful for you. Like it, share it. I will meet you with a new video next day. Till then, take care and bye.